This video will demonstrate configuring a site-to-site IPSec VPN tunnel. The tunnel will run from router R1 to router R3, and it will connect network 192.168.1.0 to network 192.168.3.0. To configure an IPSec VPN tunnel, we'll go through a number of tasks. The first task is a pre-task, in which I'll make sure that the license for the security technology package has been activated on the routers. We'll need this to unlock the IPSec and ISACAMP cryptographic features. Task 1 will be to configure the ISACAMP policy for IKE Phase 1. Task 2 will be to configure the IPSec policy for IKE Phase 2. Task 3, configure an access list to define interesting traffic and initiate the IPSec tunnel. Task 4 will be to configure a crypto map for the IPSec policy. And Task 5, apply the IPSec policy to our serial outside interface. In Task 6, I'll verify that the IPSec tunnel is operational and running. Currently, my computer is PCA right here at 192.168.1.3. I have a console connection to router R1, and I can change that console connection to router R2 or router R3 or to any of the devices that I need. I also have a PC at 192.168.3.3 that I will use to test the tunnel. In the end, I should be able to communicate from PCA to PCC through the IPSec tunnel. Router R2 will actually have no knowledge of the 1 network or the 3 network and will only recognize the 10.1.1.0 network and the 10.2.2.0 network between routers R1 and R2 and routers R3 and R2. So the communications going from PCA to PCC will be essentially hidden within the tunnel. Let's get started. I have a console connection to router R1 using PuTTY. The first thing I'll do is type enable to get to privileged exec mode and put in a show version command to make sure that I have the security K9 package and license. As you can see here from the bottom of the show version command, the current technology package is IP base K9 and security K9, and I have an evaluation right to use license, so I have access to the cryptographic features that I'll need, namely IPSec and ISACAMP. I can go ahead and begin configuring the IPSec VPN tunnel. The first thing I'll need to do is set up IKE Phase 1 and my ISACAMP policy. I'll go to Global Config mode, type crypto ISACAMP policy, and give it a number. I'll just use the number 1. And now I need to put in the settings that I'll need. I'll need a hash. I'll use the default, which is SHA. For authentication, we'll use a pre-share key. Diffie-Hellman group key exchange, I'll use group 24. I'll set the lifetime to 3600 seconds. For encryption, I'll put in a question mark, and you see I have access to 3DES, DES, and AES. I'll use AES, put in a question mark to see my options, and choose a 256-bit key. That's it for my crypto ISACAMP policy. Now I'll need to set up the crypto ISACAMP key. I'll type in crypto ISACAMP key, and for a key I'll just use a simple key since this is just a test scenario. I'll use Cisco 12345. Next, I'll need to put in the address of the peer router in our site-to-site tunnel. The peer is at router R3, and the IP address is the serial interface IP address at 10.2.2.1. So task 1 is complete. Now for task 2, I need to set up the crypto IPSec transform set. I'll type in crypto IPSec transform set, and for the transform set, I'll need to give it a name. I'll choose R1-R3 since the tunnel is running from R1 to R3. For data security, I'll choose ESP-AES with a 256-bit key. And for user authentication, I'll choose ESP-SHA-256 HMAC. I've purposely chosen slightly stronger settings by making the encryption ESP-AES 256-bit keys and the authentication ESP with a SHA-256 HMAC. Now it's time to set up the access list. I'll type exit and create an extended access list. Numbered 101, permit IP addresses from source addresses on the 192.168.1.0 network. Put in the wildcard bits, and the destination network 192.168.3.0 and the wildcard bits. The access list is used to match which packets will be destined for the IPSec VPN tunnel. Now that the access list is configured, I'll need to put it all together with a crypto map and put in all the settings and then assign the crypto map to an interface. I'll type in crypto map. I'll give it a name, R1-R3 since it's R1 to R3, -map since it's a crypto map. I'll give it an identification number of 10, let's say, and it's going to be an IPSec-ISACAMP crypto map. I'll attach my access list to the crypto map by typing in match address 101, which is the number of the access list. I'll attach the transform set that we created to the crypto map by typing in set transform-set R1-R3. I'll set my peer router to the IP address of the peer at 10.2.2.1. I'll configure some extra security by setting PFS to group 24. PFS is perfect forward secrecy, which helps defend against replay attacks and enables new random keys to be created every time there's a new security association or the security association times out and a new one's created. I'll set the security association lifetime to 900 seconds and then exit. The crypto map is now configured, and all I need to do now is attach it to my interface. I'll type in interface serial 0/0/0, which is my outside facing interface, and type in crypto map R1-R3-map. You can see the syslog message informing me that ISACAMP is now on. For the IPSec tunnel to work, you need to configure mirrored settings on the peer router, in this case router R3. I can switch the console cable to router R3 to take a look at the mirrored configuration. As you can see, I'm now in router R3. I'll type enable and show run to examine the configuration. You can see that the crypto ISACAMP policy has the same encryption, AES-256. It also uses a pre-shared key with Diffie-Hellman group 24, the same lifetime, and the crypto ISACAMP key with the same key, but the address is the mirrored address. Instead of 10.2.2.1, which is R3's serial interface, it's 10.1.1.1, which is the serial interface on router R1. Notice that under the crypto IPSec transform set, I named it R3-R1 this time, but it has the same settings, ESP-AES-256 and ESP SHA-256 HMAC. The crypto map is also similar yet mirrored. Notice the name I chose, a different name, R3 to R1 map. It's an IPSec ISACAMP crypto map, but the peer is R1's address, same security association lifetime. The transform set is the transform set on this router, and the matched address is also access list 101. But if we take a look at that access list, you can see that the network addresses are reversed. This time, it's going from the 3 network to the 1 network. So the settings need to be on both routers, and they need to be mirrored settings. I'll issue a show crypto IPSec security association command, and we can see that the crypto map tag, the local and remote identities, the peer at port 500 at 10.1.1.1, packets encapsulated are 0, encrypted 0, decrypted 0, so we haven't sent anything across the tunnel yet. Let's see if we can get this to work. I'll switch back to router R1. I'll open up a command prompt. Right now I'm connected to PCA, located at 192.168.1.3. PCA is on the same network as router R1. Let's see if we can communicate across the IPsec tunnel. I'll ping host 192.168.3.3, and if it works, it will have gone across the tunnel. I'll issue the ping. You can see I'm getting a reply. Now, I'll put in a show command from R1, show crypto IPsec security association. I forgot I need to be in privileged exec mode. I'll type enable and show crypto IPsec security association, and you can see that packets encapsulated are 20, encrypted 20, decrypted. You can see that packets are going across the tunnel. This is pretty impressive considering router R2 in the middle has no idea about the 192.168.1 network or the 192.168.3 network over here, but yet we're still able to communicate from PCA to PCC through the tunnel using a whole separate encrypted header that R2 does not see. And that is a site-to-site IPSec VPN tunnel.